0208066, I will be presenting the case study of journal with the title Effects of Zirconium Dioxide Nanoparticles Content on Microstructure and the Behavior of Titanium Matrix Composite. And these are group members. We are from Group 2 and Group 4. For the introduction part, they will be discussed three different metallic materials. It is pure titanium, titanium alloy, and zirconium dioxide. Pure titanium is the material that mostly produces aerospace applications, same to titanium alloy. But the mechanical properties was low, so to improve is using thermomechanical processing technique. Pure element of titanium alloy does not resist force and chemical attack. To balance is using powder metallurgy technique to produce different characteristic composite material. Zirconium dioxide also use the powder metallurgy technique to produce the dentistry part. In this journal, there will be discussed nanocomposite of titanium zirconium dioxide produced using powder metallurgy technique to investigate the microstructure of identification of hardness of the material and last to observe the effects of nano-zirconium dioxide content on bioresistance of titanium zirconium dioxide nanocomposite. That's all from me, and I will pass to Yongjin. Thank you.
My name is Tan Yongjin. I will present about experiment works. The experimental works of this case study is the titanium powder was used as a metal matrix and zirconia used as reinforcement ceramic materials for preparation nanocomposite zirconia ZRO2. The nanoparticle size and density of powder ZRO2 is 100 nm and 5.8. The micrometer particle size and density of powder titanium is 50 micrometer and 4.4 were used. The powder will blend according to the content 2.5 and 5 and then ZRO2 and then mix completely. And then this is planetary mouse was used for mechanical mounting processes. The mechanical mounting was carried out with the ratio 10/1 and the rotation speed is 300 RPM with the room temperature under the argon atmosphere. Besides that, we will use hydraulic compression machine to co-compress the powder mixture into ring pillars with 32 mm multiplying 11 mm multiply 4 mm at the pressure of 700 MPa. We will also use vacuum furnace to do sintering process at 1100 degrees Celsius for 4 hours with heating and cooling rate of 10 degrees Celsius per minute. The experiment works was used X-ray and SEM. The density of nanocomposites was measured by matching method. We will use rigorous micro hardness test to evaluate the mechanical properties. Next, the indentation loads of 5N was applied to sample surface with 10-second dwell time. The wear tests were done under different normal loads of 10, 20, 30, and 40. Next dwelling speed is 0.2, 0.6, and 1 m per second for 10 minutes. The pin and disc were polished with 800 grit size sandpaper. Last, the wear rate was determined every 10 minutes with an analytical balance of 0.1 mg precision.
Assalamualaikum warahmatullahi wabarakatuh. My name is BIBI INTISHAAR binti ABDUL HAKIM from SEB. My number matric is J20800425. So today I want to present about the structure and microstructure evolution. The first one is the peak of the titanium powder widen. This occur because of due to the plastic deformation of the titanium powders during the ball milling process. The ball milling process is a grinding method that grinds nanotube into extremely fine powder. The next one is no reaction between titanium and zirconia oxide during the sintering process. The next process is sintering process, which is with the increases the zirconia oxide content, the intensity peak of titanium slightly decrease. Okay, the third one is the grain size decrease, which is because of the zirconia oxide is increased. Next, the hardness of zirconia oxide has impeded grain growth in the sintering step. So because of that, it is leading a reduction in grain size and improvement in the mechanical properties. Next, the reduction in grain size, which is have an improvement in the mechanical properties. The last one is the appearing precipitation were reached in the titanium, zirconia, and oxygen. So next, we turn to the three diagram list on your right. There are three pictures that show the grain size getting smaller as more zirconia oxide is added. That's all from me. Next, I will pass to KHAIRUL and FAIZ.
My name is Mohamad bin RAZAK. Okay, I want to present about the relative density and micro hardness. For the first point, the variation in the combined sample relative density according to ZRO2 concentration.
Assalamualaikum and hi, my name is Mohamad FITRI with ZUKI. My number matric J20A0519. So my part is micro hardness for TI10 nano composites with a double way ZRO2 of the TI matrix. The highest micro hardness is 570 HV. Due to the hard action strengthening ceramic ZRO2 oxide, the micro hardness rise as ZRO2 content dose. This enhancement is the result of grain filtration and the excellent dispersion of ZRO2 nanoparticles in TI matrix. That's all. Thank you.
For the last point, the ZRO2 particle interact with the dislocation metric to absolute movement and hence raise hardness. That's all for me, thank you.
Thanks to Mohamad Faiz for the presentation on relative density and micro hardness. Assalamualaikum and good morning. I am Siti NURLIANA binti Hassan. My number matrix is J20627. Next, I will present my part, which is sliding wear. Sliding wear is a phase seals or infogging tools that occurs when two solid surfaces slide over each other with or without lubricant. Slide wear is a more of a surface phenomenon than abrasion wear. We can also measure it using the following formula, and this is known as sliding wear rate. Based on the results obtained from zirconia oxide 2, this experiment uses wear in a composite at various load of 10, 20, 30, 40 Newton, but with different speeds of 2.2, 2.6 and 1 meter per second. Due to the penetration, the sliding wear rates will increases with increasing the normal load. That's all for me. For the next part, I will give it to the next presenter, Mohamad FIRDAUS AZMI.
At the normal load, firstly, rate of the decrease with increasing zirconium dioxide nanoparticles. Finally, adding ceramic to titanium matrix made wear rate resistant and edge hazard. Change of wear rate with sliding speed. Contact load at 40 Newton. Firstly, when increase sliding velocity will make sliding wear rates increase. Secondly, when increase of sliding wear rates of nanocomposite causing and increase the surface temperature at higher sliding speed.
Based on the picture, titanium matrix have an extremely high wear rate than zirconium dioxide. Secondly, high rate of material removed from the surface of the wear rate decrease with increase of zirconium dioxide nanoparticles. Finally, log effect on the sample is alike to the sample at detection. That's all for me. Thank you.
Thank you. And my name is Mohamad. I'm talking about coefficient friction. So the load to a test under various sliding in velocity 0.2, 0.6, and 1 mFs with a load time at 10 minutes. And friction coefficient decreased by raising the normal load. They are to contain up to 10% at 10-20% reduce the coefficient of friction due to the existence of a Z to hard particle interaction. The TI and slip connect surface during the sliding action, and it will increase the coefficient of friction. The large of dropping of coefficient of friction for the non-composite is a real proof of the lubrication formation layer because of the existence of ZRO2. Thank you. Now I'm passing to my other friend, Nabilah.
Okay, for one surface, titanium with 10% zirconium and titanium matrix have two distinct effects on the one surface. Okay, for the first one, with the zirconium particles included, the composite's wall morphologies are smoother. Okay, the second, under the composite titanium matrix, the eroded scar has multiple parallel furrows and sensible craters. Okay, then when contrasted to the titanium matrix, the one surface shows some faint plough grooves and tiny craters. Okay, the last one is, due to zirconium inherent ability to lubricate itself, plough grooves are diminished as zirconium content increases, while sliding between test bin and ring increases.
So thank you to the group mates who I presented earlier. I'll be doing my part on the conclusion of this case study. So conclusively, we know that the mechanical milling and powder metallurgy are both very successful techniques used in producing the zirconium oxide and titanium MMC. And we also know that the mapping images show that the zirconium reinforcement particles were homogeneously distributed into the titanium matrix, as shown by the mapping images earlier with the different colors showing the distribution of the particles. And also, the relative density and hardness increase with the increasing weight fraction of the zirconium oxide particles. And finally, increasing the zirconium oxide particles also decrease the wear rate of the titanium MMC. So that is all for our case study on the research paper. These are the references that we use to make this presentation. That is all for our case study. Thank you. And also thank you to Chu Jia Sing and Ong Chun Hao for the slide design and the video editing.